All right, today we are going to do section 6.3. We have one more section to cover after this one. So today we are going to work on dividing algebraic fractions. It is very similar to multiplying. We'll see that in just a minute. For our warm-ups, we have to find the reciprocal. How do we find the reciprocal of a fraction? Keon? Not the opposite, because opposite means positive or negative. Switch them around. So we have to flip them. So we don't call it the opposite because in algebra, opposite refers to positive or negative. The reciprocal means we flip our fractions upside down. So they'll keep it same signs. We just switch the top and the bottom. So the reciprocal of 3/4 would be what? 4/3. I'm not going to put an equal sign because they're not the same. It's just the reciprocal. If you really wanted to, you could put like a colon next to it or something, or you can just write the answer. But 3/4 and 4/3 are not equal, so I should not put an equal sign. All right, what about the reciprocal of negative x over 2? We're going to need some new volunteers in here. 2 over negative x is correct. Everyone's capable of doing these. All right, on number 3, I need a new volunteer for the reciprocal of 3x squared over y cubed. Deja? Good. Y cubed over 3x squared. And finally, we've got x plus y over x minus y. Ryan?
X minus y over x plus y.
Good. They stayed exactly the same. We just flipped them. What was in the bottom goes to the top. What was in the top goes to the bottom. We'll move on to our division rule for fractions. I don't think that this is going to be anything new for anybody. Oop, too far. There it is. So with symbols, we have A over B divided by C over D is equal to A over B times D over C. Which we'll get to the word part in a minute, the steps below. We should be filling this part in. In general, we always say we don't divide by a fraction, we multiply by the reciprocal. So that's why they changed it to a multiplication problem, and they used the reciprocal of the second fraction. Notice that the first fraction stayed the same. All right, so off to the side in your box, I would copy down this example. We'll go through the steps in just a minute, but in general, we're going to keep our first fraction. We're going to change the division into multiplication. And we are going to use the reciprocal of the second fraction. What's the reciprocal of 2/9? 9 over 2, or 9/2. And now this looks like a problem that we would have talked about on Monday. Multiplying fractions. How are we going to multiply it? Can we cross cancel anything? No, so what should we do? Multiply what? Multiply 5 and 9. 5 times 9 gives me 45, and 8 times 2 gives me 16. Okay? Questions about this before we go to our official steps? Natalie?
If that's reduced down to something smaller, are we allowed to like reduce that?
Sure. Can we reduce this one? I don't think we can, but yes, we would want to. If nothing will cross cancel or reduce in the beginning, then nothing should reduce at the end, but it is a good habit to check. All right. Steps to dividing fractions. Rewrite the first fraction, meaning keep it the same. Rewrite it exactly as it was. Change the division sign to multiplication. Flip the second fraction. Complete just like the multiplication problems. So all we do on division problems is change them into multiplication problems. That's the only way we know how to deal with them. All right, we'll start in on our examples. So the first thing I'm going to do is rewrite my problem. First fraction stays the same. I change this from division into multiplication. My second fraction flips. So 4 goes on top now. XY goes on bottom now. Do not try to cross cancel anything until it's written like a multiplication problem. If you cross cancel when it's written as division, you're going to end up getting it wrong. We do not cross cancel until it's written like multiplication. Now that it's written like multiplication, I need a new volunteer to tell me something that cross cancels. May? 2 and 4. What does the 4 become? 2. And the 2 becomes a 1. Thank you. Anything else, Natalie?
Can we cross-cancel the x's?
We can cross cancel the x's. They are exactly the same, so they cancel out completely. Anything else? What? Oh, that's a good question. They cancel each other out, but what number could we use to replace them? Ones. So if you want to write ones by them, you can. We don't really need them this time, but you can put them. Anything else we can cancel out? Ellie? The ones, but what are they still just going to be? Oh, the y's? Can we cancel out the y's?
No.
Why not? They're both in the denominator. So they're both on the bottom, so they won't cancel out. To cancel out, one's got to be on top and one's got to be on bottom. So I don't think there's anything else for us to cancel out. So I think we're ready to multiply to get our answer. In my numerator, I've got 1 times 2. Over my denominator, I've got 1y times 1y. Y times y would give me 1y squared. Remember, if we got y times y, that's y squared. If you want to put the 1 in front of the y squared, you can, but it's not necessary. Usually, like in a textbook, you would not see it there. We should always check at the very end. Is there anything else that'll reduce or cancel out? No, so that's how we know we're done. All right, number 2. We started off the same way. Our first step is going to be to rewrite the problem as a multiplication problem. So we're going to keep our first fraction the same. What do you think I need to do to this denominator, though? Well, So we're going to use square roots, but what are we actually doing to it? Factoring. We need to factor that denominator. We might as well do that right now so we don't have to rewrite again. I need a new volunteer to tell me what that denominator factors into. Danielle? Thank you. X plus 5, x minus 5. Okay, so really we just rewrote the first fraction. We factored as we went. Changed division into multiplication. And our second fraction gets flipped. X plus 5 over 24. If you want to put your binomial x plus 5 in parentheses, you can. That helps you remember that that's stuck together. Now that we've written it as a multiplication problem, what can I do? Cross cancel. I need a new volunteer to tell me something that I can cross cancel. Kyan? The x plus 5s cancel each other out completely. Those parentheses matched. If you want to replace those parentheses with a number 1, you can. You don't really need to. All right, I need somebody else to tell me something else I can cross cancel. I'm going to need some new hands. We're going to be getting some sticks. Jalen? Can reduce by what? I think something bigger than 3. 6, good. So what does the 18 become? A 3, and the 24 becomes a 4. Okay, do we see anything else that we want to try to cancel out? I don't see anything either, so I think we're ready to write our answer. 3 times 1 in the top is 3 over, we've got x minus 5 times 4. So really we could just write that as 4 parentheses x minus 5. If you feel strongly about it, what could you do with that 4? Distribute it. So if you want to, you could write this as 3 over 4x minus 20. I would be fine with either of those answers. I'm fine if you leave it factored out, but if you really want to distribute it, you can. As long as you know nothing else there is going to cancel out either way. All right, looking at this problem from the very beginning, I should recognize that I'm going to have to do a lot of what? Factoring. We are going to have to do a lot of factoring on this one. So it is kind of up to you if you want to factor first, factor as you go, or just rewrite it and then factor later. Now, since we're just getting started, I'm going to recommend that we rewrite the problem as multiplication first, and then we can go through and do all our factoring. On the last problem, there was only one thing to factor, so it wasn't as big of a deal. But I want to rewrite this as multiplication first. So when I rewrite it, is my first fraction going to stay the same or flip? Stay the same. First fraction stays the same. And what about my second fraction? It flips, and we change this to a multiplication problem. Now, as you get more comfortable with this, you might be able to factor as you go a little bit more often. But for starters, let's just rewrite, and now we'll factor. What method, I should say, is my first numerator going to require, Natalie? The x method. What's going on the top of my x?
Negative
Negative 10. The bottom?
3.
And fill in the sides.
2
2 and negative 5. Okay, so I'll rewrite it below my new fractions. So who can tell me what this first numerator becomes? Jamal? X plus 2, x minus 5. Good. Who can tell me what method we need to factor that first denominator? The bottom of the first fraction. What do you mean by that? A GCF. Thank you, Lexi. What's our GCF? 2. What's left over? X plus 3. Factoring out GCFs does use division in a sense, but it's not called the division method, it's the GCF. All right, on to our second fraction. So at this point, I would kind of just cross out the original problem, or as long as you can ignore it, that's fine. But when I'm talking about the numerator of my second fraction now, we need to know that we're talking about after we flipped it. So what method should I use to factor that numerator? The x method. I need somebody new to help me with this x. What goes on top? Negative 12, and on bottom? Do you know what numbers fill in those sides? Anybody? Natalie?
Negative 4, positive 3.
Negative 4 and a positive 3. So I need somebody new to help me fill in my factors. Deshaun? Good. So instead of putting plus a negative, I'll just put x minus 4 and x plus 3. We've got one more thing to factor. Got to factor that x squared minus 4 in the denominator. What method am I going to use? Square roots. So I need someone new to help me factor that. Tariana?
X plus 4, x minus
Close. What's the square root of 4?
2.
2. So x plus 2, x minus 2. Good. All right. Now that we're done with all of the factoring, we can start cross-canceling. Houston, what's one thing I can cross-cancel? Which ones? I don't think I'm hearing you right. A little louder. What am I canceling out? This bottom?
That one? Are we talking about that one or the other one?
Yeah, I mean either of them. We can choose from either of these fractions to cross-cancel.
The x minus 4, x minus 2.
X plus 2.
X plus 2 and x minus 2.
They got to be exactly the same to cancel. That's why I wasn't hearing you right. So give me one thing that you see something of on the top and the bottom.
X minus 2 and...
So the x minus 2 doesn't have any other x minus 2's anywhere else. So it can't be x minus 2.
The x plus 3 and x plus 3.
Yes, that would work. X plus 3, x plus 3. They got to be exactly the same top and bottom to cancel out. Lexi, what's something else that I could cancel?
X plus 2, x plus 2.
X plus 2's match each other exactly, so they can cancel out. Do we see anything else that's exactly the same that could cancel? No. So if there's nothing else that's going to cancel, we can start writing our answer. Franklin, what's going to be in the numerator in the top?
X minus 5 and X minus 4.
Good. X minus 5, X minus 4. Keon, what's in my denominator? What else? Good. 2 times X minus 2. If you really wanted to, you could multiply this stuff out in the top or in the bottom, but you don't need to. So I would recommend just leaving this as your answer, because here, I hope at least that it's obvious that none of these things now can cancel or reduce. Okay, so it's just going to be time consuming to be multiplying things back out. Natalie?
Can't we distribute the 2 into X times X minus 2?
You could distribute the 2 down here. You could double distribute in the top. So if we were to fully multiply those back out, we'd end up with x squared minus 9x plus 20 over 2x minus 4. That is the same thing, but you don't need to do that. Does that make sense? So for some people, that's just going to take up time that they don't want to spend. And that's fine. So I'm fine with you leaving it factored out. Okay. On to number 4. What's different about number 4? Natalie?
They have a multiplication and a division.
Good. We've got a multiplication sign and also a division sign. So we can deal with this in a couple different ways. We do have to think about our order of operations a little bit here. In this problem, what's going to come first? The multiplication or the division? The multiplication. Because multiplication and division are ranked the same, so we work from which side do we start at? Left side. We work from left to right. So we start over here, work our way through. So I would recommend just looking at this first. That's the first thing we've got to do, is deal with the multiplication. We'll deal with the division in a minute. If I'm focused just on what I put in my red box, is there anything I can cross cancel there? No. Do not rewrite multiplication problems. Okay, it's already a multiplication problem. We go straight to deciding if we can cross cancel. So since nothing will cross cancel, we'll go ahead and multiply them together. A squared times 2a. Keon, what does that give me? 2a to the third power. In my denominator, I've got b times b. B squared. Now, we could rewrite this division sign and that fraction, but I know that I really want to change this division sign into what? A multiplication sign, but when I do that, what happens? You gotta flip the fraction behind it. Questions about what we just did? Okay, now that it's written as a multiplication problem, Deja, what's something I could cancel out? B, sure. So they don't cancel each other out completely, so I'm left with what? 1B. And where does it go? Top or bottom? Bottom, because that's where the bigger exponent was. Okay, so 2 minus 1 gives me 1. So b to the first, staying in the bottom. Okay? Jakeem, what else is going to cancel? I wouldn't include the 2. The a's can reduce, and what are we left with? A squared going in the top or the bottom? The top. Okay, what does this b and this a over here technically become? Ones. They become 1, so we could write that if that helps us remember what to do. So what do I have in my numerator now? 2a squared, and my denominator, b. Will anything else cancel or reduce? No, so we are definitely done. Questions about 4? Okay. Let's try number 5. Now number 5 gets a little bit tricky. Again, we've got division and multiplication, but we have to work from where to where? Left to right, which means the first thing that I have to deal with is what operation? Well, sort of, but what? Am I going to deal with this division symbol or this multiplication symbol first? Okay. Yes, we will want to get rid of the parentheses, but I need you to know that division can come before multiplication. Okay, if it comes first left to right, then we are going to divide first. Alright, so somebody kept saying we need to deal with those parentheses, which I agree, but it's not really the parentheses so much as the... There's nothing to do inside these parentheses, is what I'm saying. There's an exponent that we have to deal with. Inside our parentheses, there's really nothing to do. Nothing simplifies. We do want to deal with this exponent, though. So what do we do with that exponent? So we give it to everything in the parentheses. I would avoid using the word multiply, just because we are not going to multiply 2 by 3. We are going to take 2 and raise it to the third power. So the 2 is going to get the third power. The x gets the third power. The y gets the third power. You okay with that? That's a rule we haven't used in a while. Everything in those parentheses gets that exponent. What do you think we're going to do with this multiplication symbol? Oh, sorry. I kind of gave it away, didn't I? Change it to a multiplication symbol. That's what we want to do. And that second fraction needs to be flipped. Okay, so now I'm not even really worried about this multiplied by x over 4 yet. I will need to bring it back in just a minute. But for now, let's work on what we've got here. Tariana, what's something that can cancel or reduce? The x's. So what am I left with? X squared to in the top or the bottom? The top. X squared in the top. Kion, what's something else that'll reduce? The y's, and what are we left with? Y to the first in the top or the bottom? bottom. Okay, remember we subtract the exponents and put whatever's left wherever the bigger exponent started. Now, since our second fraction canceled completely, we could treat those as what number? Ones. We can treat them as ones if we need to. So what is left in my numerator? Okay, 2 cubed x squared. Instead of writing 2 cubed, I'd rather just write a number for that. What is 2 cubed? 8. 2 times 2 times 2 is 8. X squared. In my denominator, what do I have? A y. We have questions about that part? Keon? Yes, the 2 cubed does need to be simplified to an 8. At some point. I mean, if you don't want to do it right away, I guess you don't have to, but it'll be useful on our next step to have already simplified it. All right, what do we still need to do? That multiplication part needs to come down now. So this whole times x over 4 part needs to happen now. Yes, ma'am.
Do we have to flip the x over 4 when we bring that down, or does it just stay the same since it's a different multiplication?
That's a good question. What do we think? Should we flip the x over 4 or leave it? Leave it because it was already what type of problem? Multiplication. If it's already multiplication, we don't have to worry about changing anything. It's only when we change division into multiplication that we flip our second fraction. All right, so now that we've got our next part, we should be checking to see if we can cancel anything out. May, what do you think? 8 and 4. 8 becomes 2. 4 becomes 1. Wonderful. Nothing else is going to cancel out here. So we are ready to write our answer. In my numerator, I've got 2x squared times x. What does that become? 2x to the third. In my denominator, what do I have? Just y. Y times 1 is still y. Nothing else there cancels, so we've got our final answer. Any questions before we try some more on our own? Okay. All right, here are the first two try these problems. We'll go over them in just a minute. All right, try these. Number 1. Our first fraction stays the same, 2p over q. Division gets changed to multiplication, and our second fraction flips over, 5q over 8p. Ellie, what's something I can cancel out? Both the q's. They cancel each other out completely since they were exactly the same. Natalie, what's something else? The p's cancel out completely. Nevaeh, what else can cancel or reduce? The 8 and the 2. What does the 2 become?
1.
And the 8. Very good. All right, I don't think anything else is going to cancel out here, so I believe we're ready to go to our answer. So we're left with 1 times 5 is 5. And what's left in my denominator? 4. Anybody get 5 over 4? Wonderful. Okay. On number 2, what's something that we can do when we rewrite that first fraction? Factor it. What part factors? Okay, we can factor out a 5 in the numerator. So it's going to become 5 times what? T minus 5 or 2? 2. Okay, remember when we factor out a GCF, we divide by that factor. Our first fraction, other than factoring it, is staying the same. We could put our parentheses around that binomial in the denominator. Our division sign is changing to multiplication, and our second fraction is flipped 2 over t minus 2. Again, anytime you see a binomial, you can put it in parentheses to remind yourself that it's stuck together. Delaney, what can I cancel? T minus 2's. Good. Anything else going to cancel? Anybody? No, nothing else can cancel. Why can't I cancel this 5 with that 5? Okay, one of them stuck in parentheses as a binomial. So those cannot get canceled out together. So in my numerator, what do I have? 5 times 2 is 10. In my denominator, t minus 5. It's not necessary to put the parentheses at that point, but I think it's helpful to still remember that you cannot reduce or cancel the 10 with the 5. So we are going to have to use the x method. We're also going to have to use the square root method, and we're going to have to use our GCF method. All right. So for our first numerator, we've got our x. What's going in the top of my x? In the bottom. To fill in my sides. Good. 5 and negative 2. So I'm going to write my factors for my numerator. What are they? Y plus 5, y minus 2. In that denominator, which method are we using to factor? Square roots. So what do I get as my factors? Y plus 4, y minus 4. Now, this is a little risky, but since we're running low on time, we'll go ahead and do it. I'm going to go ahead and change my division into multiplication, which means I have to remember to flip my second fraction. So what's going to go on top of my second fraction? Y plus 4. That cannot be factored, so I'll go ahead and put it in parentheses. However, the piece that's going in my new denominator can be factored. What's our GCF? A 2. See, we're factoring this numerator, but it's going to go in our denominator. And what's left over? Y minus 2. Now, if it's confusing for you to flip and factor at the same time, I would still do that as 2 different steps. That's fine. Connie, what's something that'll cancel out? The y minus 2's cancel. What's something else that'll cancel out? Y plus 4's. Anything else? No. We still need to write our answer. What goes in our numerator? And in our denominator? 2 times y minus 4. You can distribute in your denominator, but you do not have to.